Hi, so now we will continue on the third part or the third subtopic of this chapter. That is supervised and unsupervised classification. Right. So basically, what is image classification? The objective of image classification is to automatically characterize pixels into lane cover classes, or we known as themes. So in here, why we do image classification is we want to investigate and thus grouping or classify the land use based on the pixel values on the different bands of the imagery that we have, okay, and group them, identify it, and make it into the whole image or the whole image. Okay, and the spectral patterns or the signature of each pixels derived from the multispectral stack is used for the characterization. So what we see is a spectral pattern such as different from the different features such as vegetation, such as urban, water, forest, and so on. So this special pattern will inform us or have this own characteristics for every different covers. We have different characteristics, and this will be an indicator for the computer to do the classification on the overall image. There is a different features type have different combination of these numbers based on their spectral reflectance or emittance properties. Here, as you see here, all right. So if you try to look here, especially water, this is the pattern. Okay, so the pattern will be like this. However, sand, as sand is more less water, so more reflectance, so it shows something like this. Forest, of course, they have a higher spectral signatures on the infrared, and thus going down. Urban, due to the materials of type of the concretes, so it has something like this. Okay, corn, this is vegetation. Okay, because of the nature of plantation, they have some of the soil exposure, so they have a higher reflectance as compared to the forest. And hair as well, right? So these are what we call as a spectral reflectance, and for each features or classes, they have their own different signatures. The graph is a signature, right? And thus the computer, the software will identify this, and either through our supervision or by automation, it will classify based on the signature accordingly. So the term land use refers to how land is being used by humans. So land use basically tells you about how what are the human activities on the areas or socioeconomics. So the term land cover, however, land cover is much different. It refers to the biophysical materials found on the land. Alright. For example, a national park. National park used for recreation. So national park will be a land use. How people use the land for recreation. But it covered with the forest. So for the land cover, it is forest. Land use is a national park. It tells exactly how people make use of the land. So there are two primary types of classification, which are supervised and unsupervised. For supervised, image analyst will supervise the classification by giving some input to the computer. This is what we call as a training. Okay, and unsupervised, the computer will identify itself and run automatically. All right, so we go for the supervised process. So in supervised process, this process, the algorithm permits the user to intervene or to give input during before the process, where users or The analyst will help to identify and locate some of land cover types which are known. So during this process, okay, there are many different kinds of data that can be used either through the fieldwork. We have to go down, we have to investigate, bring some GPS, go do the sunset walk, get some ideas, get the coordinates, get some photos, and you have the information about the area. Or through aerial photos, high resolution aerial photos, or maybe through maps, topographic maps, okay, detailed maps, any maps, or through experience. Could be that the trainer or the user might have some experience, or maybe he's a local there, so they know what happens, they know the surroundings, environment, so on. And the analyst locate specific sites represent the homogeneous examples on the image. So these specific sites is what we call as a training sites. Okay, and after that the computer will run the multivariate statistics for every training site, and each pixel within and outside of the training site is evaluated and assigned to the class to which it most likely belong to. So in this process, some different classification algorithms will be used. However, for unsupervised, identification and location of land cover was not known because there's no user intervention. The computer groups pixels. Okay, how the computer do it? The computer will group pixels, okay, based on the pixel range with similar spectral characteristics into a unique cluster according to some statistically determined criteria. So the computer will run some geostatistics, and after that it will go through, and based on the number of clusters that has been identified by the user, the minimum and maximum, and computer will decide accordingly, right? So the analyst combines and relabels spectral clusters into some information classes, right? And both supervised and unsupervised techniques are form of hard classifications because the pixels are only assigned to one class. So because due to the pixels, okay, land use might be much detailed. So after we do some land cover, then the analyst will try to refine it into the land use. And both supervised and unsupervised techniques are form of hard classification because pixels are only assigned to one classes, where information classes defined by human and spectral classes is inherent in remote sense data, therefore must be identified and labeled by the analyst. So computer might decide the classes, but the analyst will decide on the names of the classes. Okay, so these are the general steps used to extract and cover information from digital remote sensing data, from the start of the classification problems until come up with the processing, and of course to evaluate some errors, and then create a maps, right? And successful classification requires careful definition of required land use classes, where this require use of classification schemes that contains unambiguous definitions that are logically arranged, right? So Malaysia, basically we use the USGS LULC system Anderson, and has been modified to fit to the local needs. Okay, so this is a common use, where it is resource oriented rather than land use oriented. Okay, so there are 9 classes. Main level 1 will be the course 1. However, level 2 will redefine into the detail 1, and after that there are level 3, and until level 4 it will more and more detailed. All right, and for every different classifications, there are different kind of remote sensing data and platform can be used. Level 1, because it's quite cost, we can use Landsat. However, for level 2, 3, and 4, we require more and more detailed data to come up with the classification. All right, and after this, we will continue with the supervised classification.